So welcome to another session of Everyday Mathematics. Here at Everyday Mathematics, as we always say, we do enjoy solving the harder problems, but above all, we also do see and appreciate the beauty in the simpler problems. So today we are at the MIT 2019 Integration B qualifying exams. We look at the first 10 problems, and in the next session we'll cover the next 10 problems. But this is what we're going to focus on. Before I jump into showing you the problems we have today, I'd like to thank our subscribers. Thank you so much for the wonderful support you continue to show us. It's for your support that we here every day trying to share problems and solutions with you. For our first-time visitors, the main purpose of our channel, we do enjoy solving math problems, but also we do go out there, we look for seemingly harder problems, and then we'll come back here, share with you the solutions. Lastly, for our repeating visitors, if you haven't subscribed, we do encourage you to subscribe to our channel. Your support will mean a lot, and so please, we do encourage you to just support us. That will go a long way in giving us the extra result we need. So our problems are, the first problem is that, second problem, third problem, fourth problem, fifth problem, sixth problem, seventh problem, eighth problem, ninth problem, and the 10th problem. So our first problem is interesting. So it's the integral from x equals to 0 to 2 pi of tangent of cosine x. The first thing I'd like to exploit here is symmetry, because these are oscillating function, cosine oscillates, and the oscillation is repetitive, so I could exploit that. So from 0 to 2 pi as our domain, we could split that into 4 subdomains: 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, and from 3 pi over 2 to 2 pi. So in this region, we can keep the expression as it is and then express the succeeding integrals as a function of the primary or the initial integral. So from pi over 2 to pi, we can reduce the limits to 0 to pi over 2, but in here we can change that to cosine x plus pi over 2. Similarly, in the third subintegral, we could reduce the limits from 0 to pi over 2, but in the function cosine, we would reduce that to x plus pi. And then from 3 pi over 2 to pi, we can reduce the limits from 0 to pi over 2 and then express cosine as x plus 3 pi over 2. Now, using the cosine of a sum of two numbers, cosine A plus B equals cosine A cosine B minus sine A sine B, will yield here negative sine x. Here we'll have negative cosine x, and here we'll get sine x. And so as you can see, tangent of any negative value will result into a negative value of tangent of that absolute term. And so we're left with a tangent of cosine x minus tangent of sine x minus tangent of cosine x plus tangent of sine x. And so as we can see here, the important thing to note is this and that would cancel, this and that, and that, and this and that would cancel. So we're left with 0 as our answer. Number 2, which is the integral of x plus 1, it's an indefinite integral over x plus natural logarithm of x. We can divide the numerator by x and the denominator by x as well. So in the numerator, we're left with 1 plus 1 over x, and that numerator is the same as the derivative of the denominator. And as you know, with the integration aspect of things, when the numerator is the derivative of the denominator, that's the same as when integrated a natural logarithm of x plus natural logarithm of x plus c. So this is our answer. Problem number 3, integral of e to the power x plus e to the power x plus e to the power x minus e to the power x. So we can express this as a product of e to the power x times e to the power x. And also this one would be e to the power x times e to the power negative e to the power x. And this is the same as the derivative of e to the power x. And this is the same as the derivative of negative e to the power x. And so when we integrate this, we get e to the power x minus e to the power minus e to the power negative e to the power x. And then we have the integration constant there. So this is our answer. Number 4, which is the integral from x equals to negative a half to positive a half of 1 over 1 minus x squared. This is the same as 1 squared minus x squared. And so we can express it as the product of the difference of these two numbers, that the squares, and the sum of the two numbers. So this is the same as the integral from x equals to a half to negative a half to positive a half of 1 over 1 minus x times 1 plus x. And so we can express this as the half of 1 minus x plus 1 over 1 minus x plus 1 over 1 plus x. This is the same as after integrating half minus the negative of natural logarithm of 1 minus x plus logarithm of 1 plus x. With the limits now applied appropriately. So when substituting the limit appropriately, 1 minus a half for this, 1 plus a half for this, minus 1 plus a half for this, and then 1 minus a half. So what we're left here is a half into brackets, negative log a half plus log 3 over 2 minus another big bracket, negative log 3 over 2 plus log half. And so we can sum things up, this and this bunch together, we have 2 times log of 3 over 2 minus log over half. Divide this and that, we have 3 over 2 divided by a half, and we get a half times 2 log 3, and the answer is natural logarithm of 3. Problem number 5, which is the integral from x equals to 0 to x equals to 2 of 2 to the power natural logarithm of x. We can let u be equal to 2 to the power natural logarithm of x, such that natural logarithm of u is the same as natural logarithm of 2 to the power natural logarithm of x. And then if we take this side, so we have natural logarithm of u being equal to log natural logarithm of x log 2. And so differentiating, we get a half du dx is equal to 1 over x log 2, meaning that when we multiply both sides by x, we have x over u du is equal to natural logarithm of 2 dx. So x here is the same as when you divide both sides here by natural logarithm of 2, and here by natural logarithm of 2, and then taking e to the power e of that, this essentially just becomes x. So x is natural logarithm of u over natural logarithm of 2. And so e to the power natural logarithm of u over log 2 over u du is equal to dx. And now we know that with the limits, when x tends to 0 and x equals to 0, this is to the power log of that number with x tending to 0, so which is this tends to negative infinity at that point, and to the power negative infinity is 0, so negative infinity, so it's 0. And then the upper limit is when x equals to 2, we have to do to the power log 2. Now we are integrating u, which is this, and then in place of dx we have this, and so the u's cancels. And so we are left with the integral of e to the power log u over log 2 with the limits 0 and 2 to the power log 2. Now we can simplify this further by pulling 1 over log 2 out of our indices here. So we're left with e to the power log u, and we know this is the same as u. So our integral is the same as u to the power 1 over log 2, with the limits applied appropriately. So when you integrate that, is same as 1 over log 2 plus 1, and then times u to the power 1 over log 2 plus 1. The usual way of integrating a very simple x function of x. And then applying the limits appropriately. So when we now substitute in for with the upper limit and then the lower limit, this is 0, sorry. What we get is log 2 over 1 plus log 2 times 2, because when you multiply this by this, we get 1, and then we multiply this by this 1, we get log 2. So we get log 2 over 1 plus log 2 times 2 to the power 1 plus log 2. And this is our answer. Problem number 6, the integral from x equals to negative 2 pi to positive 2 pi. And so the product of cosine 3x and plus sine 2x and negative sine 2019x plus cosine 3x. So we can solve that quickly by multiplying, doing a hard multiplication, such that we have the integral of negative cosine 3x sine 2019x plus cosine squared 3x minus sine 2x sine 2019x plus sine 2x 3x. Using the identity sine a plus sine b equals to sine a plus b over 2 cosine a plus minus b over 2, and when cosine a minus cosine b is considered, that's same as negative 2 sine a plus b and sine a minus b. So using these identities, we can attack this using this identity. So we get negative sine 2022x plus sine 2016x, and we'll leave cosine squared 3x as it is. And then here we have, in place of this negative sine 2x sine 2019x, we have cosine 2021x minus cosine 2017x. I have forgotten to include half here, forgotten to include half here, forgotten to include half here for sine 2x cosine x, which is cosine 5x minus sine x times a half. Okay. So with halves applied appropriately here and here and here, as you can see, when you integrate sine 2022x, is the same as 1 over 2022 negative times cosine 2022x. Now cosine of 2 pi and cosine of negative 2 pi is the same value, so when you subtract those values, you get a 0. So the same thing applies to this, same thing applies to this, same thing applies to 0. And with this, when you integrate this cosine 2021x, you get sine 2021x over 2021, and sine of 2 pi times an integer is 0, same thing with the negative 2 pi. So same applies to this, so this also tends to 0, 0. And so you're left effectively with the integral of cosine squared 3x. Now the term we have, anyway, let me not touch that. So the next thing is we want to do is express this as a double angle format, and then this is cosine 6x plus 1 over 2, and then we know that the integral of cosine of an integer times x is 0, so we know this tends to 0, so we are left with just the integral of 1, right? And so this is the same as x, and then 2 pi and negative 2 pi as the limits, upper and lower respectively. This results into a half times 4 pi, which is 2 pi. So this is our answer. Integral of cosine x times cosine sine x times cosine sine x. Cosine x is the same as the derivative of sine x. And the product of the derivative of sine x and cosine sine x is the same as the derivative of sine x And the product of the derivative of sine x and cosine sine x is the same as the derivative of sine x. And this is the same as sine x plus c when you integrate this. Now, number 8, which is the integral of e to the power negative 2019 over 4t squared over t squared. What you want to do here is express this entire thing as a square of something, which is the square of square root of 2019 over 2t. And we can say let u be equal to the square root of 2019 over 2t, such that du dt is the negative square root 2019 over 2t squared. And so that means that 2 multiplying both sides or dividing both sides by this constant over square root of 2019 t squared du is the same as negative dt. And then t squared is the same as 2019 over 4 times 1 over u squared. And then we sandwich it in there so that now this comes 1, this divided by 2, and this cancels, and we're left with square root of 2019. So we're left with negative square root of 2019 over 2 du over u squared is equal to du dt. Sorry. And so substituting this into this, we have when t tends to 0, u tends to infinity. When t tends to infinity, u tends to 0. And then we put in du, and then in place of t, we substitute in u. So we had substituted for dt with this expression here. Going in, we have negative 2019 over 2, integral from u equals to infinity to u equals to 0 of e to the power negative u squared over square root of 2019 over 2u squared times du over u squared. And then when you simplify it further, we get 2019 in the denominator times 4. And then we have 4u squared here. So this u squared and this u squared goes, and this divides 2, and then we have a 2 there. This goes, and we're left with 2019 square root. So we get a constant of negative 2 over a square root of 2019 with the integral from u equals to infinity to 0 of e to the power negative u squared. And then because of this negative, we can flip the limits appropriately, and we see that this is half the Gaussian integral, obviously. And so to consider the entire Gaussian domain from negative infinity to infinity, we have to have half of the entire integral there, since this value is symmetrical about u equals to 0. So the 2 goes, and so we have 1 over square root of 2019 times the integral from u equals to infinity of e to the power negative u squared. And so this is the same as 1 over square root of 2019. This integral is the same as root of pi. So we have root of pi over 2019 as our answer. Number 9, we have the integral of sine of square root of x. We can let u be equal to square root of x, such that u squared is equals to x, such that 2u du dx is equals to 1. So 2u du is equals to dx. And so integrating sine of square root of x is the same as twice u coming from here, sine u. And then, as we can go that further, we have u derivative of, since sine u is the same as derivative of negative cosine u, and using this as a dv, and the v being cosine u negative, and this being our capital U, so that when you're integrating by parts, we get the product of u and v, which is negative u cosine u minus the product of the derivative of u, which is du, which is 1, and then v, which is cosine u. So in brackets, 2 times u, negative u cosine u, this derivative, this integration results into sine u, and then plus the integration constant. Now we can substitute back for u with regard to square root of x. So our final answer is 2 times sine of u, which is sine of square root of x, minus u cosine u, which is square root of x cosine square root of x, plus c. And that is our answer. Number 10, which is the integral of from x equals to 0 to 1 of the square root of x over 1 plus x. We can say let u be equal to square root of x, such that u squared is equals to x, and so 2u du dx equals to 1, and so 2u du is equals to dx. Now, when x equals to 0, u is equals to 0. When x equals to 1, u is 1. And so this becomes the integral from u equals 0 to 1 of u in place of square root of x over 1 plus u squared times, in place of dx, we have 2u du. So we have it here. This results into 2 times the integral from u equals to 1 to u squared plus 1 over u squared. And when you divide that, probably you get 1 minus 1 over u squared, 1 over 1 plus u squared. Integrate that, we have 2 times u minus arctangent of u. This is a popular integral. We know that to be the integral of 1 over 1 plus u squared would be arctangent of u squared, arctangent of u. And so substituting in the limit 1 and 0 respectively, we have now 2 times 1 minus arctangent of 1 minus 0 minus arctangent of 0. This entire lower bound goes to 0, but here we have 1, and here we have this 10 going to pi over 4. So I'm applying 2 by 1 minus pi over 4 becomes 2 minus pi over 2, and this is our answer. So thank you so much for hanging on with us. It's been an absolute pleasure solving these problems. If you have any questions, please don't hesitate to leave comments in the comment section. We are open to suggestions. We're open to any other ideas. But thank you so much for your support. If you're not subscribed, please subscribe to our channel. We really appreciate that support. Until next time, adios. Thank you.